Hello again, Geometry. It's Mr. Lamb coming to you with page 3 from the Unit 2 test review. And let's just keep on doing what we've been doing, working with triangles. Question number 16 is an exterior angle of an isosceles triangle. So I could think about this and say that the exterior angle is equal to x plus y. And that would be well and good. But as we remember from Algebra 1, if you have one equation with two unknowns, there are a whole bunch of possible answers it could be. So I'm going to try to get some more information. So I'm going to first take a look at this straight line right here. And I know that a straight line has to add up to 180 degrees. So if I said 180 minus 96 is 84, this angle right here is 84 degrees. And now I'm going to look at the triangle. Because of these lines right here, these little markings tell me that this triangle is isosceles. And I know that isosceles triangles, base angles are congruent. So that means y is also 84. So to find x, I know that a triangle has to add up to 360. Or I'm sorry, a triangle has to add up to 180. So 84, so I'll take 180, I'll subtract 84, I'll subtract 84 again, and I will get x to be 12. So x is 12 degrees. That way, 12 plus 84 adds up to 180. Also, I could say 96 equals x plus 84, because an exterior angle is equal to the sum of the remote interiors. And I could have subtracted 84. 96 minus 84 is also 12. All right, question number 17. This is a proof. You have the statements and reasons below. I'm not going to necessarily scroll down because I want to be able to show the picture up here. But I'm going to take a look at all the different statements and all the different reasons. And I'm going to try to build this proof. So the first statement says that DE and BC are parallel. I want to draw that. So these two things are parallel to one another. And I know that anytime I have parallel lines, two parallel lines cut by a transversal, that alternate interior angles are congruent. So if you look at the two parallel lines, and now let's look at AB. Two parallel lines cut by a transversal, this angle and this angle have to be the same, because those are alternate interior angles. So I'm going to write that. And in the proof, you will see one of the statements says that angle DAB is congruent to angle ABC. And the reason is this big long reason down here. If two parallel lines are cut by a transversal, so if two parallel lines, blah, 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 all of that stuff. If two parallel lines are cut by a transversal, then what is true? Alternate interior angles are congruent. And if you just write alt-int angles congruent, I get that. Right? I understand that shorthand. Right? If you are going to shorthand something, make sure that I'm going to understand what that shorthand is. All right, going back and looking at the picture again, those two parallel lines, let's look at a different transversal. Let's look at transversal AC. Right, transversal AC, I again have alternate interior angles. So as I look through my list of statements, I have angle EAC is congruent to angle ACB by the same exact reason. This is the same exact reason. So let me put that right there. That is the same exact reason. Number 4. Number 4 says that angle DAE equals 180 degrees. The reason for that, as I take a look at my reasons, are that they are supplementary angles. All right, as we look at line 5. So line 5, I'm looking for the statement that is angle addition postulate. So angle addition postulate just simply says that I'm taking smaller angles and I'm adding them together to equal a bigger angle. And that is found when we see that angle DAB plus angle CAB plus angle EAC is equal to angle DAE. And now DAE, understand, that is a straight line as well. So that is the same angle that is that straight line, DAE. All right, and the last thing that we have, by process of elimination I could get there, but I want you to look at line 4 and line 5. I say in line 4 that angle DAE is equal to 180. And then in line 5, I have these three things that add up to DAE. So I'm going to make the substitution right here. I'm taking out angle DAE and I'm plugging in 180 degrees. That is the substitution that is made. So this is substitution. So the substitution that's made is angle DAE gets replaced with a 180. Everything else stays the same. So angle DAB plus angle CAB plus angle EAC. Those three things will add together to equal 180. And that is the proof, question number 17. The last video will be for page 4.